Missed a button. Hello, everyone, and welcome to the broadcast. We're continuing our build of entity behaviors, the underpinnings of how the entities move around and behave. We had a previous system, we've got a better system in the works now. Paired with the fact that we have much more efficient handling of this processing and rendering, we should be able to get away with a bit more complexity, which we are working on today. Before we get into that, though, let's check in with the kitties. We do have. Well, looks like Sky has usurped Ember's spot there, snoozing away. We have Mason and Sherbet on the bed, left to right. Ember has taken position on the adjacent table, and Sammy is on the shelf. If you were to draw a line from where Ember is facing, like almost the direction of her nose, you would run into Sammy, facing the opposite direction. But yeah. I think we should still be functional, so let's show folks this is where we were. He's bouncing away. I added this red dot for testing. I've got just one of them rendering. If you look, they're actually facing right, which is the default direction that they're supposed to face. Next thing that I want to do during the rendering is to make it so that they're looking at the movement direction that they use and determining if we should flip the X. If you're curious about the rendering, it's that the UVY coordinate is the opposite as far as the texture that we want to use when we're dealing with this pattern. I don't know why that is the case under all of this, but it seems to be, and now it's addressed. Which means we don't need to try to do like a 180 rotation or anything like that and assume that everything faces left by default. So that's good. This is where we'll get that scaling, but we do need an entity actual direction out of it before we can really do this. Hey there, Skylar. Welcome. That cat is Sky. He is cozy. Light is really hitting his fur at the moment. Okay, so I made the gate object. I have another streamer friend that's name is Sky as well. Thinking. Okay. So we made the gate object last time, I think. Either way. We have a Boolean to determine whether it's open or not. And behaviors have a gated property. I'm making a game, Skylar. And in particular, we're working on behaviors. We have... Let's see if I can open it for you here. It's in a Krita file still. Never mind. We are changing the way that we were processing movement. A core pattern in the game. Just show you some blobs here for now. We're going to add 50 at a time, and we're going to go up to the full 15,000. And I'll run. Hey there, James. This might be apparent, James. I got the facing working. It turns out that the Y coordinate on the UV and shaders is inverted compared to the Y on the texture, so it was rendering them upside down. Yeah, Skylar, for quite a while we were primarily doing gaming, and it just kind of struck me that this programming was a skill set that I had, and I've always like started dabbling in game design. Back when we did Noida primarily, that's kind of what I was doing with the mod, is I had very heavily changed the way the game played for our stream. And this is not only an opportunity to go further to actually make a game, but it's an opportunity to exercise more of that lore, which I like. Okay, so we've got the blobs moving. We have a gate entity. The first gate that I've created is the timer gate, which whatever you've set this to, once it gets going, whenever you try to open it, it will say, okay, well, how much delta has passed since you last tried to open it? Is there time left? If there's no time left, it'll say that it's open. And then we will proceed. So in the catalog, we've set up a gate, and we're going to make a 3-second gate. Now, to make this viable, what I'm thinking is we're going to set up... Yeah, we're going to set a gate on move random direction. Gate, wait 3. Okay, it's now gated. Which, once we get this rolling, we're gonna artificially do it for now. But what this will mean is that this will create a segment. First, we have the base behavior of the weapon, which we are going to bundle into a behavior group here. And then we'll have the move random direction behavior, which will not activate until the gate triggers. Well, thanks, Skylar. I think you joined a little after, so let's show the other ones. We can see all 5 cats right now. So you saw Sky. For you, Sky is in the upper left. Then we have Ember on the white table. We have Sammy over on the shelf. She is the little tuxedo. Ember is the orange and gray and stripy one. Then we have Mason and Sherbet on the bed. Mason is on the left and his brother Sherbet is on the right. Okay, so we have the gate. In order to do this, when the entity manager spawns one, we have created the entity. We need to mess with it now. So we'll just brute force this at the moment. Behavior. Equal to entity dot base behavior. Oh no, okay, we have to go through the behaviors. All right. So until we find a gate, that's the first one. We're going to make a behavior here. And then How we do this? This is an iterative loop essentially. We're going until we're out of behaviors. No, we can do this. We can do it this way. So the entity has. Let's look back at what we did last time. So the entity has a base behavior, and then it has a stack of behaviors and a stack of gates. So we're going to, whenever we encounter a gate during this process, we are going, after we take the first one and make it into a new base behavior. Hey, Goku. Welcome. The tricky part of this behavior of this pattern is going to be getting the base behavior. We know that's going to be the first one, but we have to kind of prime the loop. So at the end of a check, as we're going through each behavior, we need to be adding. Okay, we're going to add to the existing new behavior until we hit a gate. At that point, we retrieve the gate. We create an instance of that gate, add it to the gate collection, and we start building the corresponding behavior for that one. With a special logic that says if the collection is, if this is the first one, we set it to base behavior instead of adding it to the stack. Otherwise, we add it to the stack. All right. So we have the new behavior, which is a behavior group. For each behavior in entity dot base behavior. Oh no, we know what the base behavior is. So the first behavior group becomes a new one which we add the base behavior to. Okay. And we're not copying anything here. Then new behavior dot what's it called? Yeah, this one. Dot behaviors, which should be public because we need to edit it. Okay, new behavior. entity dot base behavior. So we're going to need two things. We're going to add hopefully when we're for eaching over the stack, it'll go in the right order. For those of you that may or may not be, that aren't familiar with the channel, we are doing some game development, and a lot of what you're going to hear is stream of consciousness as I'm thinking about this. I'm just going to say what I'm thinking about at the time. Might deviate into conversation, but if you have a question or anything like that, fire away. I will, as soon as I notice it, I will try to respond. So when we look at the catalog, loading so its base behavior is this. So then entity behaviors. Push okay, so we're building the base behavior first. And then as soon as we hit a gate, we have special logic that will create a new group, add the existing one it'll create a new group. It will append that it'll append that into the behavior stack, and it will so we've created this, we've primed it. It is the base behavior that we're messing with. So then we do entity.baseBehavior is equal to new behavior. So we've taken the existing behavior of the entity and loaded it into a behavior group, which is now the base behavior. We're doing that because anything before the first gate, between the original behavior and the gate, becomes part of the base behavior. It becomes an intrinsic part of that projectile that will always happen. Once the gate is hit, though, so we are going to there's no gate, then we add behavior to new behavior. There is a gate. Okay, so if there is a gate, we're going to get that gate. We're going to add it to the gates. We're going to create a new behavior. That is another behavior group. new heavier. New behavior. So we get a copy of the behavior that was in the existing list. We add it to the new behavior. And then add new behavior to behaviors. Let's say push. So what this is going to do is everything will initially go into base behavior. As soon as we encounter that first gate, we're going to add the gate. We're going to create the new group. And we're going to push that first one into it. Behavior dot is gated. This is new. And behavior. Okay, we're also going to need Ember's all loafed up. She's a bit disgruntled. You can see from her posture. Sky is in her spot. Sky will trot over and use her as a pillow periodically. Maybe some mutual grooming, but uses her as a pillow for the most part. And if she gets up to move and he stays there, she won't go back. Ember is remarkably non-confrontational. So her posture right there is not like, I'm super happy. She is normally laying on her side a bit. She'll only take that posture if she's on something plush. Now alternately she just wants to toast her belly. That black thing is a low output heating pad. Add catalog copy behavior. So this is, we're copying it, we're popping it into the existing one. Oh, hey, Okaneki. Welcome back. Gate is equal to catalog dot get. Don't have a get gate. Gates. But would I ever consider cosplaying? No. It is unlikely that I would ever appear in public. It's a long ways to above ground from inside the factory. Get gate. Behavior.gate key. Entity. No worries, Skylar. I mean, it's not like you asked, hey, when are you going to do a face reveal? Because I really want you to do a face reveal. So I've created a new list of behaviors. List of gates is equal to new list of gates. These are going to override the entity's existing stuff. Again, we wouldn't really do it this way, or at least this would not be where we're doing it. There would be more robust logic for setting this kind of thing up. We would probably have all of this predefined so that we could populate the entity with it in advance. We would not be doing this per entity created. Well, I appreciate the sentiment. New behavior is equal to new behavior group. Behaviors, add, catalog, copy, behavior. Gates. Push. This is a stack. Push. Behavior. Okay. Hello, Tass. Right now, this is the hacky version. This is the proof of concept version. We're not going into depth because these structures are going to be like, these stacks are going to destruct as it moves along. Additionally, this is a one and done. So at the time a spawner is created from a weapon or for the monster, all of this gets done once. Then what it will do... originally, back a couple of iterations, movement and targeting were recursive. It would do the, punch to the end kind of thing. And then flow the results back up. That went through some passes, but... Okay. Making sure I've got this. So this first iteration right here, new behavior is primed with whatever the base behavior of the entity is. Then, as long as we don't find a gated one, we're going to keep adding to it. This first test is intended to be they move in a random direction for 3 seconds, and then they're going to move in a different random direction. We are going to go into our entity manager here, and we are going to change that. Again, this whole physics process here where we're massively creating a bunch of them, this is not end state. You're in the alpha-eest of alpha testing at the moment. Okay. So then, in our entities movement function here, let's check and make sure we don't have... We never initialized this guy. Gates is equal to new dictionary. So load gates. Save us a couple of crashes there. That's not true. We're assigning to it right there. Don't care about that one. Then in the entity itself, so we do base behavior.act. This will always happen. So now what we're going to do is first we check the first gate. Gates. We have a gate. And Do we use the double character thing in C#? Or something else? Syntax. Nope. Syntax for and. Is it like, that? Yeah. I can see anachronisms. Okay, so if we have a gate, and we try to open that gate and it does, what we're going to do then, and if we have a gate, we have a subsequent movement. Pop the first gate. Okay, so now the first gate is popped. Alright, so we have two stacks. We have a stack of gates and we have a stack of behaviors. Each gate corresponds to a behavior that cannot be done until the gate is done. So there are two states that we can be in. We can be in a state... Hey there, no. We'll get there. We can be in a state where the gate is open, or we can be in a state where the gate is closed. You should be setting is open. Okay, this doesn't need to return a bool. We effectively have an active. No electrical engineering, no. We're coding the behavior system for entities, bullets and monsters and whatnot in the game. In a game we're making. And part of that process... Here, let's... Part of that process is, upon certain conditions being met, moving on to different behaviors. It does have a similar vibe, James. It does have a similar vibe. Okay, nothing's getting created. What did we break? What did we break? Okay, so we have should have an entity now. It has a base behavior. Then it has a move straight line. We're going to create local behaviors and gates. We create a new behavior. Wait, what? Why did that? Oh, that won't help us. Behaviors is null. Behavior group. See this cool initialize function we've got here? You see how we're not calling it? Let me do another. That'll do. Okay, their base movement is still working. This is good. So they are getting through this. So now if we go into entity act, this is where this is where the new fun happens. So for the purposes of gates, we have to get to the next one. I'm trying to go for kind of a low detail kind of sprite art vibe. So yeah, we're currently using 16 by 16 as our base resolution. That might bump up to 32. Okay, so we have the case where the count of gates and the count of behaviors is equal. If that's the case, we do not pop the front of the behaviors one. That gate has unlocked it. If the number of gates is less than the number of behaviors in the behaviors group, then we do pop the existing front of behaviors. Okay. So we pop the top of the gates. Okay, we can't. We need to deal with this first. If hello, Mud. Hello. Okay, we are always going to pop that gate, though. Trick is if before we pop the gate, there is a different number here, then we're going to pop the first behavior. Okay, so let me talk through this here. We have a parallel collection of gates and behaviors. You cannot execute the behavior until its gate is gone. So we're going to call try open on it. If it opens, then first we say if the two collections are lined up. For the most part, this means that it's the very first one. That is, I have an equal number of them, so none of them have an open gate. If that's the case, the first gate just opens. We just pop the gate. Past that point, though, we're going to alternate on these cases effectively. No, past the first time. This is the first time we do this, we will not pop the behavior because this is the first gate. We will now begin using this behavior. Ember noticed that Sky left her spot. She has reclaimed it. Okay, so the first gate is open. So we won't remove that first behavior. We haven't worked with it yet. So once we've got this down, first we're going to say if behaviors.count is greater than 0. We're not going to do any of this if we don't have extra behaviors. So if we have extra behaviors, then we're going to say behaviors.peak if behaviors count is greater gates count. Okay. We have extra behaviors. We need to do the check. We check if we have a gate still and that gate is open. Then we're going to reveal the next valid behavior. Whether that means we have to remove the current one or we just open the gate. Now, this last one should never go away. It might deactivate itself, but it will never go away because there's never going to be a subsequent gate. If the number of behaviors is greater than the number of gates, that means we have an ungated behavior to execute. So we say behaviors. Wait, you can always do this. No, this has to be. Peak act. This so if we have an exposed behavior, there are more behaviors than gates, we're going to execute that behavior. And the first gate, the one that exists inside the base behavior, does not count as a gate. This should totally work. See these guys that are moving real slow? That tells us it's working. Here. We're going to change the number of entities that we generate. Just going to say 10 of them, and we're going to go into the catalog, and we're just going to wait. Well, we'll wait 3. Three's pretty solid. This little guy here. Now, it's possible that their movement stays the same, but this guy going slow means he has 2 conflicting move random directions. Let's change it down to just one little guy so we can keep track of it better. Well, sadly, he booked it. Okay. So now, what I want to do is get another type of movement in place, and then not gate it so that we can get some alternates in here. Okay, we can do that. Let's get a debugging one in. So we have a move straight line. We have target random direction as a targeter. What it'll do is it'll just pick a direction. Previously, I had tried to use like delegate functions on this kind of thing, but I don't want to get too deep in that regard. That was starting to get kind of convoluted. Just going to grab all of that. Boop. That's target right. So then in our catalog, when we load, there's got to be a way. I got to find a way to have the the internal file explorer. It's got to be something for that. Like, jump to functions kind of thing. It's very handy in the Godot engine, but Oh, what do you know? Thank you. That's convenient. Also, let's get the targeter in there first. If that's the case, then I should be able to move these all back up to the top, but they're okay there. Now, I might change this subsequently that is target fixed direction, but for the most part, target fixed direction isn't terribly viable. We'll see. We'll see. For the most part, if I want a fixed direction, right is a good default. So now we have target right. So if we load behaviors, we have move straight line. It has no gate. Which means it will be added to any existing behavior. Which is fine because it's going to be part of the base behavior. We want to emphasize the difference here. Back down here, this is actually target random direction. This one is going to be Come on now. Okay, so now we have a move right. If we go into our entities now, so its base behavior is going to be movement right. Then after 3 seconds, it will move in a random direction. It's going to move pretty quick, though. I feel like we need some sort of concept of speed, but I think we'll get there. For the time being, we're just going to real quickly... It's going to move at half speed. Okay, it immediately started doing that. The gate is not... All right, what's going on, you? Fine, fine. Hey there, Dorothy. We need to make sure that we're dealing with the active properly, but... It shouldn't have a move random direction as its base. Okay, I think... Hello, billboard. Alright, I think I see part of the problem. Ember managed to retrieve her spot, so Sky came over to use her as a pillow again. All snugly. I think we're going to be able to see all 5 again, unless Mason is hiding. Nope, all 5. Ember and Sky all snugly. Sherbet on the side of the desk, and Sammy on the shelf. And Mason on the bed. Okay. I think the problem is in this flow. So we're going to go into that entity again. We're going to get into its act. Pretty much. So we're loading the nanoblob. Its base behavior is moved to the right. It's a move random direction with a target right. Oh. It's not. One more time. No worries, Billboard. No worries at all. Okay. Still doing wrong thing. Let's... When we are spawning them, let's put them at 0, 0 as well. I'm keeping this block here because it's kind of convenient to spread them around. So, launch it from here. Oh, wait. I copied it, but I didn't change it. Godot editor being annoying. There. Stay right where you are, please. Entity, act, we're going to go there. We launch. Back to here. Look at our entity. Behaviors is a stack of 1. Base behavior, which is a behavior group, has a move straight line, which is correct. It is not gated, and it has a target right. It is going to move to the right. We have extra behaviors. There's nothing in gates. That's not right. Hello, Minty. Okay. Gates is not being populated. But yes, it is. Got to keep an eye on that phone battery. Thanks for swinging through. Oh. Yeah. Okay. This is entity dot gates. Thank you. That's when we copy it, so that's going to be a problem. Okay, it's still firing through too fast, but that's one issue solved. So let's go when we're creating the thing. Okay. To step over. We have retrieved a base blob, which has a behavior which is the target random direction with a gate. So it will be considered gated. Then we have a base behavior, which is the move to the right. So we are creating wait for it. Okay. See these cool stacks right here? That we go and we populate them with stuff. Where do those go? Oh, we've been doing this all night. Dot. Moving right, random direction. Yeah. Right, moving right, random direction. For the giggles, we're all at 0, 0. And then we're going to add them one at a time. Okay, this is not quite correct. They're not hitting that marker properly. So we need to make sure that we're not... The gate was all the same gate. As soon as the first one was done, they all opened up. Moving to the right, scatter. This is what we've been working towards. What this means is that we can daisy chain it further. And that's what we're going to do. So we're going to have a series of random directions that come off of this. All right. So right now it has one move random direction. We do need to make sure that we're accounting for the fact that it's a push. Oh, this won't work right. It's not a queue. Because it needs to be first in, first out. It needs to be a queue. It needs to be a queue. Yes. If these are stacks, it's first in, last out. Or, last in, first out. However you want to call it. But they do need to be in order. We're generating them in order. Commence the air generation. We are enqueuing them, apparently. Q is one of those words that's easy to start spelling, and sometimes it feels like it's hard to stop spelling. U, U, E, U, E, U, E, U, E, U, E. Okay, still functioning. Now we needed to do that because of what we're going to do here for next. Go into our catalog. We're going to put that gate back on it. So we're chaining gates. We are going to need to test chaining non-gated elements and make sure that they get lumped together properly. So then we load entities again. So we have movement, random direction. Okay, we should get a different movement pattern now. Moves to the right. Random direction, still moving in the right. Now they shift right again. So we should start to see, we're seeing, if you look, some of them are deviating more to the left here. We can actually... Let's switch the sequence here. Oh. These just be behaviors. Okay, they move right. They spread out. They start moving right again. Two-stage movement change. We're getting there. Into random direction. Into move right. Into random direction. So you can see narrow, cone, straight line, cone, straight line, cone. Now, one of the elements, and the reason that we're not getting much movement this way, really, we're not getting any movement this way at all to the left, is because this movement to the right, this steady movement, is always there. We always have a vector 96 to the right. The way that these operate, there is no way for them to push against this enough. Now, they can stop in place, but they cannot resist this push. Isn't that cool? Shall we, yeah, we'll do 10 at a time. Look at that. Now, think about the extra checks that we're doing constantly. We're still holding steady. Interestingly, no. No. These numbers up here, the top one is frames per second. The lower one is the number of blobs. We're holding steady. Part of the reason that, like, the fact that we're operating in C# now is because of that. When we were operating in Godot, this number couldn't go beyond 2500. All right, there's our first proof of concept. Now we need a way to test combining the movement. So the first thing I want to do is look at... Okay, so we have the entity's direction and target direction. This is for daisy chaining targeters. So, for example, if we have a movement pattern that says home in on a monster, and then I have a second movement pattern that says home in on a monster, they will not pick... Well. Okay. Tracking flaked. They won't pick a different monster because ideally I will code them to say, oh, there's a target entity and I don't have a target entity yet. I'll just use that one. In a similar vein, if it targets the player, it might be, it says, oh, I target a monster. That's the player, not a monster. I'll pick a monster. So that's what those are for. We need a... it's not proposed movement, it's... I think it actually is proposed movement. So what proposed movement is that's we go through all of them. The reason that it's proposed is we don't take action until the end of it. This is going to be a change. Behaviors aren't going to actually edit that, edit our position anymore. They're going to add to this. Ultimately, this is Godot engine. See all these nodes? Yeah, these aren't the nodes we're using. Build. Run. We're using C#. So let's look at the actual. We'll look at local. Sorry, remote. So root, we have our core, we have our game. We generate a mesh renderer, and inside that there's 4 multi-mesh instances. There is 1 multi-mesh for every texture that exists. This is not ideal. Perhaps one day I will figure out a way to do this differently while maintaining the efficiency. But for the time being, what this means is that this is always the player. The player is always rendered on top of everything else, except this testing square. We were originally coding everything in GD script over on this side. We have since stopped doing that. Now everything is over on the C# side. We're going to take that proposed movement. We are going to move you up with position. Why do I do this? It's a valid way to do it. Picking a project to do is a good way. I mean, frankly, is the way to learn a programming language. It's, hey, I'm gonna make a game, and during the process of that, you'll learn to make a game, and you'll learn to use whatever tool set you use with it. Okay, so we have proposed movement. Let's see. Position. So now we go in and we say proposed movement. To vector 2.0. Zero out the proposed movement. Subsequently, all of these things are going to change proposed movement. And then at the end, we have position plus equals proposed movement. Okay. This is relevant. And I think this is going to help us get a spiraling motion that is better than the prior iteration. So now we go into behaviors, and we want to go into move straight line to adjust that. So instead of position, we're going to have entity proposed movement plus equals that. Now we should get the same result after doing this. Okay, same result. The code editor that I'm using is VS Code. Just the freebie one that you can get from Microsoft. I think I have a license for one of the, it's several years old for Visual Studio, but I didn't want to go through the hassle. Okay. So we now have proposed movement. We have proposed movement working. We are now going to have move spiral. I may have to look into that and see if it'll be stream viable. There are some tools that Microsoft makes that have a desperate need to plaster your initials over everything, and it can be a hassle. We're just going to duplicate move straight line for a moment here. Okay. So when we spiral, we have a radius. And we have... So that's how fast the radius is growing. And then we have how fast it rotates. Spiraling and orbiting are kind of staples of the genre that we're working in. Double. Get set. Yep. So my proposal here, James, is instead of the more complicated calculation that I was previously doing that could run into issues, I'm going to be essentially looking at we're going to look at where the position of our current proposed movement is going to place us. And I'm going to look at where, based on the entity, I should be proportionally. So I'm going to draw a line to the entity and say, like, okay, this is the position on the spiral that I would be. This is the, point on the circle. But I should be closer or further away, kind of thing. So then we're going to rotate. We're going to push towards where it should be. That way, the spiral is kind of relatively stateless. The only thing it has is, like, how big is my radius currently? So we're going to do that L thing again. Plotting math. Dealing with the fact that there's so much spatial math going on in game development is reminding me how much math I've forgotten. Okay. So we're just going to go with crude vectors for the time being. So we're going to expand outward at the same speed that we move along the circle. So the first thing is we need an outward force. We need an initial outward force that is going to default to the target or target direction. That will definitely give us our starting point. Okay. Okay. We're going to say from entity. I'm just going to call it from entity. Equal to. From. All right, we're just going to start with it being our. We're going to start with it saying 0, 0. It should be based on its target's position. But lacking a target, it needs to set itself to its origin. Do detected to center. All right. Center is either something that moves or not. It's if I have a target entity, center moves. If I do not have a target entity, it is whatever position the entity is in at the moment that it determines it. This is kind of a hassle if the center is actually 0, 0. But that is only an issue for at most one frame. I don't ever want it to be an issue. Okay. Okay. We start with, 0 radius, and the center is not set. If targeter dot entity is not null, center is equal to what now? Targeter. So, if there is an entity, we override the center. Good point. Not center is set. Entity dot position. All right. If there is a target entity, then we are going to words and things. We're going to update it. We're going to update where the center is. If there isn't, then if we haven't set the center, we're going to set the center to wherever we are right now. So, in the case of our test, that's always going to be 0, 0. Sherbet has moved up behind my head, so I gotta slouch more here. All right, so we have a center position. This is relevant because that's going to be what we check our 0, 0 can be the center. For the purposes of our test, that's going to be the center. Because there won't be a target entity and it's going to spawn at 0, 0. So this will be 0. Okay, so then we're going to go from the center to our current position. Sherbet, what you doing? Doing, buddy? Oof. So Sherbet never lets me trim his claws. Which means when he walks down you, one, hopefully he walks across tougher fabric. But additionally, he's prone to having to kind of disentangle his little murder mitts. But this is relatively rare. He has walked down across me from my shoulders and is letting me give him intensive scratches. So he gets intensive scratches. Very slowly managing to get past his skittishness. It is definitely going to be a bit before I try to trim the murder mitts, though. I haven't, James. What is the hole in the cardboard box trick? Well, with any luck, it will be useful. Okay, so we need to draw. We're going to draw a line from the center to the entity, to the object that is supposed to be circling. We are going to get the length of that vector. First, we're going to apply our current radius plus equals 96 times. For those that haven't been watching for long here, 96 is previously was what we called 1 square. And the reason that's 1 square is that is a 16 by 16 tile at a scale of 6, which is the scale we use so that everything is not super tiny on the screen. My tracking is really flaky today. 1 second. We'll see if that works any better. But not looking great. We'll see. We'll see. If okay. This is needless calculation if we are already at max radius, but adding the ifs means it's a needless calculation if we're never at max radius. So we'll just do the addition and then stomp on it as needed. Vector 2. Position minus center. If technically this would be more efficient because we could generate current radius squared and then we can calculate this, but subsequent math becomes a hassle. So we're gonna potentially touch from center length multiple times here. So we're gonna say double. We don't want to do this multiple times because we have to do square roots during this. And even though I'm not worried about doing it once per frame per time we're doing this, I would be annoyed to do it multiple times. That would be wasteful. equal current radius. We are not where we should be. So let's see here. We have a default speed of 96 for this purpose. For getting into position that we should be. That matters if the object is well out of range of its target. If from center okay, so we're going to check this. If it's 0, targeter dot direction to 0. Okay, so if we don't get a vector from center, that means we're right on the center. So we're going to try, hey, what is the targeter direction? We'll use that as our from center here. And current radius will never be 0 at this moment unless delta is 0. Delta should never be 0. As we wouldn't call it if time had not passed. Thinking. Okay, if it's not 0, then from center is that. Else, from center is equal to vector 2 dot right. All right, this is the maximum distance that we are going to move along from center. So we need to determine these two are not equal. Okay, vector 2. move to edge is equal to this is the difference between them. So we need to make sure we get this right. The direction to the entity is from center. And that's how long that is. That can be further than the radius, or it can be closer than the radius. If it's further, we need to move inward across the vector. We need to negate that vector. So it is going to be the length of the vector should be the radius minus the length. You don't want to just snap to that position. We'll deal with that in a moment. Okay, same thing is if we want to move to the edge, we have entity position. That's our position. No. Wait. This is where we are from center. This is where center plus from center dot normalized times current radius. As a float. Okay. This is this is where it should be. This is on the edge of the radius from us. No, we don't care about this. We shouldn't care about that. See that in a moment. Okay, so this is the point on it that we are currently at, or that we should be currently at. We're not. So then... Okay, so this is out from the center. We're going to rotate it. We could just rotate it right. Okay, so we're just going to rotate it 90 degrees to get that. Times 96 times delta. Again, these need to be floats. We're keeping a lot of this stuff in double form because a lot of it, by default, in the C# side is a double. We're only translating them to floats when they need to go to the Godot side. That is a loss of precision. Shouldn't ever be an issue, he said. All right, so this is where we should be. So now we're going to say, not a variable, 2. Okay, so it's edge position minus entity dot position. Float speed is equal to float. Okay, first. Okay, this gets us the direction that we need to move in. If to move Okay, if we don't have to move the full length, then speed is equal to an entity proposed movement plus equals to move normalized times speed. Okay. Let's get this thing loaded and we'll see if it works. Constant string. Spiral. Going to default to the right, and then we'll move out from there. Let's see here. Doing this because we want to be able to figure this properly. We got one more piece. Nope, we should be set. We should be set. Cast it. Its radius is equal to spiral dot max radius. Current radius. To spiral dot. Okay. Hello, Sammy. Okay, we are not going to set a max radius. We want it to just spiral out. Then when we're loading this little guy up, we're going to start that. See what happens. See what happens. Well, it's doing a thing. This outward force, I think, is an overriding factor here because it's constantly going to be moving. We should be getting a push upward. We should always be getting a push in the right direction here. So let's take a quick look at what's happening. In this case, there's no gate. We've just got the base behavior. Because I wanted to see what would happen. Center should now be 0, 0. Yeah. Okay. Skip that. From center. Okay, we're sitting at 0, 0. Hello, Yuki. Well, then welcome back. Okay. around again. Have it from center. Going slightly further out now. Make a lot of sense that it's moving left as a result of this as well. We recently went in and did two major revisions, Yuki. We switched over to C#, wildly improving performance, and now we're adjusting the way that we perform movement. Let's see here. Oh, this is why. Because we're pushing this harder and harder. It is getting shoved to the side. We don't want to multiply it by the current radius. We want to multiply it by the maximum change. So there's essentially there's a speed to the edge that we need to account for here. It's how far we need to go to get to the radius, and then how far we should be moving along the circle. One second, be right back. Okay. I forgot to take any breaks, so, you know. Okay. So, as I was saying, we have a couple of factors. Our actual speed. This part is correct, I think. This is the part that says, all right, how fast am I moving along the circle? This technically isn't quite right. The longer delta is, the less accurate it is. But given the performance that we're seeing, shouldn't be a problem. This is the one that is wrong. This should be a special speed. This is, again, this part right here. Same for the radius. Okay, so we have... Let's release that so we can gracefully exit. Okay. So right here, we would be determining what our kind of our expansion speed is. So double last radius to current radius. So the trick with that is, James, we're not just spiraling, we're spiraling at a point, and we're spiraling out from that point as individual movement. So if we were just spiraling, not adjusted by anything, that should work. But as soon as... Yeah, it's orbiting or spiraling from a central position is where things get different. Trying to decide how I want this to operate. So the way you're describing it could be fine. With the rotation based on... Base the rotation, the angle on... That should definitely work. Because then we have a change in angle, and we have its, its linear speed. How would we translate that into orbital motion? because we still need the same general behavior. It needs to spiral out until it reaches its target radius, but it needs to do so gracefully. It can't just snap, you know? That might ultimately not be a problem. Because we could just have it be a tighter angle. How would we keep pace with a target centralized one? Yeah. So if it is from a fixed point, then I think we could do the rotation thing. Just changing the vector. Which has some advantages to it as far as how it would blend. I think that creates its own interesting patterns. But if we're orbiting a target, that creates extra movement. That is, we're not just rotating in place, we're trying to rotate towards that target as well. And we need to move there in a pattern that matches kind of how we'd be rotating anyway. So, like, if I have a whole bunch of them that have spawned out and they decide to leap to another target, then we need to be able to get them to converge. Like, if they need to converge into orbit, or if they need to, like, spiral in on that target. That also removes... This one's a bit of a puzzler here. Because when moving independent of a central point, that is potentially variable, we could just turn. Could we accomplish it otherwise, though? Let's keep going down this road. We'll figure it out from there. Okay, we just need... double... radius minus last radius is the speed. What's that? This is kind of the velocity limit on towards the edge of it, towards our point of rotation. Else. Okay, So this is how fast we can move along the edge. So. And then this is how fast we move, I'm sorry, towards the edge, around the edge. Well, he'd be wiggling. Which makes me think that I messed this part up. Our current radius, we adjust it by its speed. So this is as far as it can move. It could get to the edge. And it will either use... It's either going to use speed or it's going to use the distance to the edge. So current radius should always be expanding. Because this should approach 0 as we get near the radius, but well, let's step through it and see what's going wrong. Because the initial turn is off, but it shouldn't be just wibbling in place, because we should have that, again, that push towards the edge that is as fast as the movement along the edge. Zero. Current radius is now non-zero. Have an outward speed here. We're starting out moving to the right. Edge position starts out as move to the right. And then it is right and down. This makes sense. To move is right and down. This is already accounting for speed. It's already accounting for speed. Yeah. We've already accounted for all of this. It's double applying speed, which is going to skew the rest of the algorithm. Which doesn't seem to have changed anything. Hurrah. Still wibbling about in a circle. This should apply a quite big vector at this point. Or at least we should be applying a pretty steady vector out. But maybe that's part of the problem. Are we ever going to do that? Because I want to be able to circle to a target. This is the only reason that we're pursuing it in this direction. If I just needed to have the perpetual pivot, then we'd be fine. We could run with your suggestion there, James, where it's just, keep turning slightly kind of thing. What we do... What is going wrong with this? Radius is expanding out. It should be much further out. Now we could have it be proportional outward pressure. But I feel like this should still be working. The vector should always be kind of at an angle around it. But we might need to come up with an increasing outward pressure to keep forcing it further. Like kind of like a lerp motion, you know? know what? Let's roll with that. Let's roll with that. We could composite that, I think. Yeah, we could have logic that keeps rotating it. We could have logic that pushes it away from the entity or, like, pulls it in or out like a spring force towards the radius. Let's just roll with that for now. Do. And let's just rotate our... Well, we'll get there. We'll get there. Because we do want to add this. Yeah. I think you're on point with that there, James. Okay, so we have vector 2. We already have a vector, use it. Otherwise... need to verify how we do targeters here. Let me take a look here real quick. We need to call update target. All right. Right. Okay, if the targeter gives us a direction, otherwise we're just going to say move to the right is the vector we're dealing with. No. Okay. 3 stages. If proposed... Okay, if we're already moving, we're going to use that direction. If we are not already moving, we're going to use target direction. If there's a target direction. If there's not, we're just going to say it's to the right. No, that still doesn't work. There needs to be, if this is the first one, then there is no proposed movement yet. So if the spiral is the very first one, we still want it to be moving. We could store off last movement. But that's not accurate. We do need a facing. Like a direction that it's pointed. That should ultimately be... Oh, dear, dear, dear. The problem was if it needs to be however the entity moved last if we want to have the steady rotation. It can't be the direction that the spiral moved last, otherwise we're going to... well, it could be the direction the spiral moved last. We could store that off. It means the spiral is, after it begins, independent of outside stimulus, though. As soon as it's moved once... I mean, we could also have it's like, oh, there's no proposed movement. I will initialize it with my last motion. Yeah, that's the thought there, James, is that I wanted to handle the current one. Like what we're moving now. So if it says move to the right, the prior one would apply a rightward angle, and it's going to turn it down and push it away. So we would constantly have that move a little to the right, move a little down, move a little down. I guess what I'm getting at, Tass, is if it has no source direction, so we don't have a previous motion. It's just, it starts at 0. The projectile has entered existence. If the vector is acting, if the spiral is acting by itself, we could say, hey, take right, and start rotating. But then it needs to remember I was last moving right, and I need to rotate again. So it's applying a rightward force initially, and then it keeps applying that force. But if there's a direction that we're already moving, we should respect that. It does not, James. It's the whatever behavior is first is the one that supplies that motion. And yeah, it's whatever behavior is first is the one that begins supplying motion. Oh. No, let's think back to what we were doing. It rotates it. Period. That's all it does. It rotates. So if there is no proposed motion, it doesn't do anything. Doesn't care about the target or doesn't care about anything else. If there's proposed motion, then vector 2 is that. Oh, time speed. Okay. Rotates it, adds a push. Rotates it, adds a push. Well, that's what we're about to do. One of these times I'm going to remember to hunt for where the degrees to radians is hiding in the C interface of Godot. Or if I can find it in like math or something like that. But for the time being, times pi over 180. Ultimately, I suspect that's what such a function would do anyhow. Okay, then what we do with this one is we put it after move random direction. Or right, or whatever. with the beginning. Behaviors. Add. Here we go. Oh. We need to... First time this came up is a behavior group needs a targeter. It doesn't actually need to be anything, but behaviors have to have targeters. Which... A behavior group. Not abstract, all it has is a virtual. It can do nothing. Okay. And then a behavior group by itself will... no, we need that in initialize. Just overrides the targeter. That should get us past that particular nasty little exception. Not quite. Let's... Our turn. All right, this isn't pushing outward from... So the combination isn't what we would want here. Because it's not like proposed movement isn't is always coming in as the same thing. Good point. Let's verify. Okay, so proposed movement is currently a random direction. We're gonna rotate that a little bit and add our speed to it. So we have applied a rotation of that vector. But the thing is, proposed movement is always going to be the same thing. In this case, I don't think it's working incorrectly. It's that spiraling off of a random direction isn't sufficient. We still need a force outward kind of concept. So that we always have a push from the direction. Okay, we need to think on this one a little bit further. Because we need a outward, or we need an additional force to pair with the rotation that is going to ensure that regardless of how the rotation happens, that there's an additional push like away from its center. Otherwise, we don't necessarily get that precursor motion, the proper precursor motion. So let's say the random direction is to the right. What's going to happen is it's going to apply 1x, let's say. And then we're going to get to this, and proposed movement is 1 to the right. It will then take that, rotate it slightly. It'll be, a little less than 1, a little greater than 0 kind of thing. It will pump the speed on that. It'll be about, 1.6, close to 0. And it will apply that. That will happen every time. It's just going to be a slight veer off in that case. We could increase or mess with the angle to apply a greater push to it, but that also means that eventually we can get... That makes it so that we start to run into problems with, like, additional rotations, because they can cause each other to, like, each individual rotation starts to have a fixed, I'm going to rotate this far kind of thing, which creates oddities. It's not a contextless one or a stateless one, We want them to be as stateless as possible. Let's think on that some more. Spiral, I think, is one of the most apparent, one of the most visually apparent things we can do. So we need to figure out how to do this one. It is an excellent demonstration of the system. All right. But more progress made. We definitely demonstrated sequential movement. So the system in general works. This is where we want to be. We are finally back to making new movement patterns. We are revisiting some of them, but we get to do them in, I think, a more robust fashion. We just have to figure out how to realize it, What is the combination of things that make a spiral? What is the combination of things that we need to get that sine wave working, But yeah, I hope everybody had a good time watching with us tonight. Nice little learning experience, and we didn't hit one of those mental dead ends until the very end. We did run a little over. But that's fine. That's fine. I had a good time. Hope you did too. In any event, if you like what you saw and would like to see more, remember to like, follow, subscribe, that sort of thing. If you'd like to financially support the channel, there's Patreon, Coffee, and channel memberships available. Neat little emotes and whatnot on YouTube. I hope everybody has a good rest of their day, and I'll see you next time.